Hi class, in this recording we're going to be focusing on PhysioEx exercise number 5, activity number 1. And as we're looking at our exercise overview, I can't emphasize enough this equation. This is a super important equation that you need to focus on. This equation will help really just explain everything that you need to know for activities 1 through 4. And if you can understand the math behind this equation, you're going to be golden for the first 4 activities. So as we're looking at activity number 1 is asking you to look at blood vessel radius, so the radius of the blood vessel, and how that affects the rate of flow of blood. So really it's just an application of the above equation that I highlighted for you. And as we're looking at this exercise, you can work through the directions, get some data. Something that's troubling about your lab manual is that your lab manual has the independent variable listed second in the data table and the dependent variable listed first. And that's a little irritating because normally most data tables will have the independent variable listed first. Remember that independent variable goes on the x-axis of a graph and the dependent will typically go on the y-axis. After working through your experiment, you will end up with some data, and this is what your data should look like. So we can see some data right here. We have our flow rates, our radii, viscosity, pressure, etc., etc. And as we look at that data table, a key concept or a key idea for you to get the trends out of the data table is to ignore the columns that are unchanging. So viscosity is unchanging, length is unchanging, and pressure is unchanging. The only two things that are changing is the radius of the blood vessel and the flow rate of the blood. And as we're looking at that on those two columns, if we plot radius on the x-axis and flow rate of blood on the y-axis, we end up with a curve that slopes upward dramatically. This is a positive exponential curve. And this positive exponential curve is exactly what we would have expected if we were looking at some kind of equation that had a positive exponential in the numerator, like this one right here. The rate of blood flow and the radius of the blood vessel. So the rate of blood flow is equal to a whole bunch of stuff here. For activity number 1, we're going to focus on radius, and radius is to the 4th power and in the numerator, so we should see a positive exponential on that graph. Let's look at our review questions. As we look at the review questions, review question number 1 asks you to describe the relationship between vessel radius and flow rate. Well, let's look back at the data. As radius goes up, flow rate goes up. It is a positive relationship with an exponential slope to it, a positive exponential relationship. Let's look at question number 2. Question number 2, review question number 2, it asks, in this activity, you will alter the radius of the flow tube by clicking plus and minus buttons. Explain how and why the radius of blood vessels is altered in the human body. So we're asking here, how does the radius of a blood vessel change in the human body? The technical terms for this are vasoconstriction and vasodilation. The constriction or relaxation of the smooth muscle within the tunica media of our blood vessels. Question number 3. Describe the appearance of your plot of blood vessel radius versus flow rate and relate the plot relationship between the two variables. As we look at that plot, it's a positive exponential curve. As the radius goes up, the flow rate goes up. Question number 4. Describe an advantage of lower blood viscosity or flow rate in some areas of the, I'm having a brain hiccup right here. It says velocity. I promise I can read. Velocity, not viscosity. Describe an advantage of slower blood velocity in some areas of the body. For example, capillaries of our fingers. The slower the blood moves, class, the more time there's going to be for nutrient exchange. Whether we want to get rid of those nutrients from the tissues, take those nutrients away from the tissues, or add those nutrients to the tissues. So the slower the blood moves, the more time we have for chemicals to be exchanged with the blood. And that's all we have for activity number 1. If you have any questions or comments, please feel free to post them in the class discussion boards on PhysioEx. Happy studies.